Okay. And present. Wait, hold on. This is a random question, but can you see what do you see on the screen if I do this?
Black bars on like the sides.
Do you just see the presentation though?
You see, I see the presentation, but then I
Yeah,
also see like the tabs and stuff at the top.
Okay, that's good. Okay, yeah, so we can start.
Okay, so this week we're going to be going over coordinate planes and functions. Yeah, so that not this week, today. So that's the topic for today.
Okay, so today's agenda. So today we're going to go over, first we're going to go over the coordinate plane, like the basics, what the quadrants are and how to plot points. And then we're going to go over functions and what constitutes a function. Then we're going to learn about linear equations such as slope and then the different intercepts like the x-intercept and the y-intercept. And then we're going to learn about lines, how how you can make a perpendicular line and how you make a parallel line with the equation. And then we're going to do a lot of practice problems and an activity in Decimus. And finally, you guys are going to have some homework.
Okay, so first, before we get started into functions and graphing lines, we need to learn about the basics of what x and y are for those that don't know yet. So we're going to be taking a look at a coordinate plane. Just gonna... So a coordinate plane is made of a y-axis and an x-axis. So y is basically just a vertical and x is horizontal. And x is always going to be how far left or right, and y is always going to be how far up or down. We're going to be looking at a real example on a coordinate plane. So I'm just going to present that. And we're just going to show what x and y are.
Okay, I can't see my tabs because of this. Hopefully I'm picking the right one. Okay.
Okay.
Yeah.
So this first value that we're sliding to the left and right, that's our x. And that's going to be in the top. You can see the coordinate a comma b. So a is going to be the x value, so left and right, and then b is going to be up and down. So b is going to be our y value. So when you're expressing coordinates, it's always going to be x comma y. This should be fairly trivial. So if you don't understand this, then you're kind of screwed for the rest of class. So this is very important. So yeah, x comma y, x is horizontal, y is vertical, and that's how you're going to express any point on a Cartesian plane.
And also, if you guys see the point moving, it says like quadrant something at the top. So this one, the point is in right now, is the first quadrant, and then it goes counterclockwise. So the second one is on the left top, and then the third one is down here at the left. Then the fourth one is over here on the right.
Okay, yeah, and also it's important to know the first is always going to be positive, comma positive. The second is always going to be negative, comma positive. The fourth is always going to be negative, negative, comma negative. Or the third is always going to be negative, comma negative, and the fourth is always going to be positive, comma negative when you're expressing it as a coordinate.
Oh, and so just one thing, let's try out. So in the chat, say which quadrant my point would be in if I went to -4, 2. Okay, so I'm seeing a lot of 2s, and you guys are correct. So if I go here, I can't make it exact, I don't think, but that would be kind of where it is. Oh yeah, I did it. Okay, so it's, yes, in the second quadrant. And no, it's not in the fifth quadrant. So let's go back to our presentation. And okay, so okay, so remember that increasing the x coordinate value moves the point to the right, and decreasing it moves the point to the left. So we just saw that on the Desmos thing we just did. And increasing the y-coordinate value moves the point up, and decreasing it moves the point down. So I think we all got that. So first, we're going to try to do some practice on a coordinate plane. So this is going to be a Jamboard. So I don't know if you can see that right now, but we'll put the link in the chat.
Yeah, I'll put the link in the chat. Or Kyan can do it.
Wait, I think I might. Hold on.
I can do it if you want.
No, I have to do it because yeah.
All right, that's fine. Yeah.
But I feel like you might not be able to edit it. So tell me if you can.
Oh, it likes to make a copy of it.
Okay, so that is not good. Yeah.
All right, I can send the editable.
I can't access it.
All right, yeah. I sent a new link. That one should work fine.
Huh, that's the slides.
Oh, sorry.
So
Wrong thing.
guys, don't go to that one.
No, don't go to the slides. Oh no.
So just ignore that and pretend.
Yeah, don't. Oops. All right, where is it? Oh, it's here.
Oh, here, I think I know how to.
Click editor. You make
You
an
just
editor and then
click. Yeah.
copy the
No,
link and then
I got this. Sorry, guys. As you can see, I'm not the best at computer stuff.
Kyan's really bad with technology.
Yeah. Oh, oops, what happened? Okay, so hopefully you can edit this one. So does it work? Can you edit it? Just like scribble something on it. Okay, thank you. So, okay, so basically what we're gonna do is, so if you see on the left, there's like a bunch of points, and there's like what? How many people are in this meeting right now? Not including us.
There's 15.
15, okay. So there's 12 section thingies, and some of them are long. So we're gonna try to assign you guys to like these sections so that you can just graph your points, and at the end, we're gonna be able to connect them. So don't start on them yet because we're gonna be splitting up into sections. So basically, okay, this is gonna be kind of hard to split up, but I'm just gonna go through the participants list and attempt to split this up. So please listen to what I'm saying and like pay attention to which section you're in. Okay, I kind of don't know how to look at who's in here. So can you do that, Rochelle or Gopal?
Yeah.
what?
Okay, so yeah, you can do it, Rochelle. So you should probably split up 2 into like 3 sections and then 5 to 2.
Okay. All right, this is confusing. All right.
Okay, wait, hold on. We can do this instead. So just in the chat, put your name. So I'm going to say who wants to do the first section. Just put your name and then I'll just call a random person. Okay, so the first section will be Sahil. I might mess up a lot of these names. The second section, the first half-ish, you can do it, Advika. And then the second, like third-ish, you can do it, Harsh. And then the third, you can do it, Vishwa. The third section, Hashir can do it. The fourth section, okay, Aishwarya, you can do it. The fifth section, the first half, Santoshi, you can do it. The second half of 5, Charvi, you can do it. 6, Shreyan can do it. Yeah, I'll like just draw a line where you would stop. And then, yeah. So you can't hear me properly. I don't know what to do.
You might want to check your audio settings.
Yeah, look at your speaker. Yeah, okay, so other people can hear me still. And then the 7th section, okay, who doesn't have a section yet? Just put your name. Okay, 7th section, you can do it, Tanisha. You don't know your section. I think you were like, I want to say like 3 or something. Okay, so I don't think this is gonna work. So, okay, just write your initials next to a section.
Okay, so you're on the Jamboard, right? And we split it up. So just write your initials next to whatever section and take that section.
Yeah, if there's like
If there's
another
no
person-
initials next to the section, then
yeah, just like take a section and start graphing. And if other people graph the same point, so be it. As long as we finish this, it's okay. So you guys can just roughly divide up the sections, and if you finish and there's some section that nobody has taken yet, you can do that too. So you can just start graphing with whatever color you want. And I think you guys can just use like the pen tool. So that's like the first thing at the toolbar on the left. So that should be easiest. Oh, and when you guys like can guess what this is, just put it in the chat. So as more people graph, if you want to guess, you can just like,
People are erasing mine.
oh really?
and don't erase other people's.
This is kind of common sense, but please don't erase a point. If you think it's wrong, we can figure that out at the end. So for now, just don't erase anything.
I probably won't spend much time on this because there's like 30 points. So
No, but there's a lot of people, so it's gonna go fast.
we'll go until like 9:50 latest.
Yeah.
Someone's writing over mine.
Oh, that's okay. As long as if you like write on the same point,
We can still see yours. Like there may be 2 points that are like the
Also,
same.
Don't connect points right now because you have to do that at the end.
Yeah, but there may be several points that are the same, like because there's a lot of points. So if somebody's writing over here, that's fine. But that probably just means that you guys have the same point. Or I mean, we can still see your point, so it's shouldn't be too worried about that.
Okay, we'll go until like 9:50, and then I'll review what this is supposed to be. Someone deleted yours. Oh, it's okay at this point. So, okay, this is gonna be kind of hard, but you guys, let's just for fun try to guess what this was supposed to be. So since I know what it's supposed to be, I can see like where the outline is, but if you don't know, it might be really hard. So I'll give you a hint.
If you don't know, it's
An
kind of
animal.
impossible.
It's an animal, okay?
It
And
isn't.
it's like,
A bear?
That's close.
no, it's not a cat. It's not a bear. I think.
You're close. Like it's honestly
Yeah.
better than I expect. Okay, dogs much closer.
Tiger, no. You guys are like kind of on the right track. No,
Whoever
it's
the
not a
dog.
butterfly.
Okay,
Okay,
somebody
someone
got
has the answer.
Tryon got it.
Yeah, it's a wolf. So if you guys can see
it
like
obviously looks so much like a wolf.
no, like you can see the nose, like somebody like outlined it, and then the years are at like the first and second quadrants, and then the face is kind of incomplete. But it's a hard one to do. So since we didn't like connect, okay, the wolf is there. So I think you guys all plotted it like right for the most part. So good job. And it was kind of just for fun and practice. So we'll get more like official.
Mainly if you like understand the concept of what a coordinate is.
Yeah.
I think I think we can see that you guys know what a coordinate is. So
Good job.
All right.
Okay, now we'll go back to the presentation. So, okay,
Now we're going to do functions. So, what is this? A function is like a machine. It takes in input and then it outputs exactly one output. So, this means that every function so a function is basically defined as for every input, there's exactly one output. So it's like a one-to-one kind of correspondence. And so let's take a look at the function f of x is equal to 2x plus 3. And for every x value that you input, like you can input the value 1, you'll get exactly one y output.
Be careful. A lot of people think f of x is f times x. F of x is kind of like saying, y. So if you do f of 2, it'll be like f of 2 equals 2 times 2 plus 3.
yeah,
Yeah.
Yeah, so every time an input x is input into the function, a value comes back as the output. And a function is only a function if each input has exactly one output. So
so this is just like a chart that shows an example of some points. Oh, shit, what did I do? Okay, so if you see at the left, there's some examples for functions. So the second one, like the one at the bottom of the left box, you can see that two different x values point to one y value. So it's like when two different x values are put into the function, one y value comes out. That's okay. So it says each input should have exactly one output. So both of these inputs have exactly one output. So that's okay. But on the right, you can see like, for example, the first one on the right, the 9 points to both the 3 and the -3. So it doesn't have exactly one output. It has two outputs. So that's why that's not a function. And the same thing for the second one, because the 3 is pointing to 5 and 6. Yeah, and f tells it's a function. So like that's what it represents. And it doesn't always have to be f. It can be like a different letter too.
yeah, it could be like g of x or like h of x. F of x is the square root of a function. Or squared x. Is that a function?
I don't really understand what you're asking.
Are
Sure.
you asking if the square root of x or if the square root of x is a function?
Sorry, I should have put a little more detail. Because the square root of 9 is 3 and -3.
Well, usually when you ask the square root, you always mean the principal square root. If you say something squared is equal to 9, then it would be -3 or 3. But if you're asking for the square root of 9, it's going to be 3.
Yeah, it's kind of a technical.
When you put square root, it's always asking for the principal square root. If you're doing something like, so as Gold posted, if you're doing something squared equals 9 versus the square root of 9, I know it like appears the same, but like the square root usually means the principal square root.
So that's just like the positive one you would think of. So we're gonna go over these.
Yeah, so in the chat, type in whether the example is a function or not. So the first situation is going to be based on a list of unique names. The first name is inputted and the last name is outputted. So
this means there's nobody with the same name.
yeah. Yeah, so this is a function. It's pretty trivial. So for every input of a first name, there's going to be an output. Nobody can have two last names. So the next example is if the name of a person is inputted, their age is outputted. That is that a function or not? So we're getting some answers.
Yeah, so that's why I said no one has the same name.
Yeah. So we've gotten yes multiple times. So that is the correct answer. Nobody can have two ages. So that is a function. The third example is if the name of a person is inputted, the names of two of their friends are outputted. So this one's also pretty trivial. You guys should be able to do this like without and like flawlessly. Yeah, so we've gotten a lot of no's. So yeah, it is not a function because there are two outputs per input. And the last example, just to finish this, is this a function? So we have something similar to the last slide. So 1 corresponds to K, 2 corresponds to M, and 3 corresponds to L. So is this a function? Yeah, we've gotten more answers. So it's pretty much just yes. Okay, we have a question on the first of explaining the first one. So the first one is based on a list of unique names. The first name is inputted and the last name is outputted. Can you like type in the chat what you need us to clarify? Oh, how is it a function? So the definition of function is for every input, there is one unique output. So it says the first name is input and the last name is outputted, and it said a list of unique names. So there's no way that two people can have the same first name and different last names. So for every first name that is inputted, there's one unique output. There's one unique output, and that would be the last name. So it just matches the definition of a function. So
Yeah, so these are like typical number functions. This is kind of just practicing that there's one output for each input. Oh, okay, so this is also continuation of checking if a function, well, if a like graph is a function or not. So if you might have heard of this, but there's something called the vertical line test that lets us see if a graph is a function or not. So if a vertical line intersects more than one point at any part of the graph, then the graph is not a function. So for a graph to be a function, if you draw a vertical line over any part of the graph, it should only intersect once. So one thing to note is that it doesn't matter if the vertical line test works for some or even most parts of the graph. If at least one point causes it to not pass the test, then it's not a function. So
a lot of people think things like parabolas, ellipses, and circles are functions, but like they're not. And you can see that through the vertical line test and just through the definition of a function. So don't be confused when you do that. Well, some parabolas are not functions. Some parabolas are.
So like you can see the first one, which is kind of just the squiggly line, it is a function because the vertical line, no matter where you move it, it's only intersecting one point. But the second and third one, wherever you, like when you move it, some parts of the graph or all parts intersect at 2 points instead of 1. So that tells us that it's not a function. So here, I'm just gonna like quickly attempt to draw something. So hopefully you guys can see this, but tell me in the chat if this is a function. And use the vertical axis.
Yeah, so we've gotten a lot of answers.
Yeah, so a lot of you guys are saying no, so good job. Since the vertical line, it works here and like here, but it doesn't work in like this part. So that's why that would not be a function. So good job, because everybody got it right. Okay, so now on to the next slide. Okay, there we go.
So now we're going to move on to linear equations, and we're going to learn about the different forms regarding linear equations. So first, there's going to be slope-intercept form, and this is when linear equations are in the form y is equal to mx plus b. And m in slope-intercept form, m is going to represent your slope, and b is going to represent your y-intercept. And the y-intercept is basically the point at which the line intersects the y-axis. So there are other forms of linear equations other than slope-intercept form, such as point-slope form or standard form. But most of the time, you're going to be using slope-intercept form.
You should be most familiar with slope-intercept form because that's what you're going to use most often.
Mhm.
It's very seldom that you're going to have to be forced to use point-slope form.
But it's like good to learn it though.
Yeah, it's good to learn, but
I never used.
yeah, you don't really use it in math. You use it in math, but you don't use it in competition math.
Yeah.
Yeah.
Rarely.
So the
Oh.
equation for point slope form is just going to be y minus y1 is equal to m times x minus x1. And again, m here is going to be the slope, and then x1 and y1 are just going to be a point on the line. So it's good to like find the equation if you know the slope and the.
Okay, so we're going to be going over slope. Slope can tell you a lot of things. The very basic definition is how steep a line is, but obviously that's not going to help you when you're finding an equation. So the formula, well, the definition, the mathematical definition of slope is the rise over run. So rise is the change in the y value, and x is in the change in the, and run is the change in the x value. So slope just equals vertical change over horizontal change. So if we look at this graph here, when you're looking at a line, you want to plot 2 points where the line intersects like a good coordinate point, like not integer coordinate points. So in this line, all the points are integer coordinate points. A lot of times they're not going to be. So you just choose 2 random points. So in this, we have chosen 1, 2, and 4, 5. And so in this, we can see that the rise is going to be 3, and the run is also going to be 3 because the change in x is 3, the change in y is 3. You can also choose like 2 closer points. So no matter what, you're going to see that the slope is 1. So any graph that looks like this, the slope is going to be 1. If it's steeper, the slope is usually going to be higher. If it's not as steep, the slope is usually going to be lower. And there's also a couple other indications that tell you what the slope is usually going to be.
Okay, so on to the next slide. So we're going to go over, wait, hold on, yes.
Yeah, so here's an example. So I want you guys to calculate the slope of the following line. So type your answer in the chat. Remember, it's just the rise over run, change in y over change in x. Remember not to get it mixed up. So type your answer in the chat. Nice, so we've gotten 1 answer. This is pretty, you know, you should know this very well. It's pretty basic in terms of AMC algebra. So if you have any questions at any point, definitely ask, or any confusion, just because without knowing stuff like this, there's no way you're going to be able to learn the more advanced concepts.
And like, if it's your first time, like you're being introduced to this, it's okay if you like don't understand.
Yeah, so Sahil, we will, like, when we solve this question, we will go over the change, we will go over how to solve for the slope. It's easier to learn when you're looking at real examples. So we've gotten 4 answers. I don't know if you guys have gotten any private messages. So I think we can, 5 answers. I think we can go over it now. You shouldn't spend too much time on this. Well, you should spend time learning it, but not too much time solving it. So the slope is 2/3. So going back to the formula, it is change in y over change in x. So the change in y is going to be 4, I believe. Yeah, so it's going to be 3 minus -1, which is 4. The change in x is going to be 4 minus -2, which is 6. So then when we do 4 over 6, we get 2/3. So essentially, yeah, so what Gopal put in the chat, that looks a little bit complicated, but that's just because it's kind of hard to do math typing in Zoom. But yeah, it's just the change in y over change in x. That's really all there is to it.
One thing to know,
Somehow you can explain it. If you have any more questions, feel free to ask.
okay. So we're next gonna go over intercepts. So there are 2 types of intercepts. So this is like, we're basically going over linear ones today. So the x-intercept is where the line intersects the x-axis, which, if you remember, is the horizontal line on the coordinate plane, and it's in the form x comma 0. So if you like don't understand what this is saying completely, we'll look over it a little more later, so don't be scared. And the y-intercept is where the line intersects the y-axis, which was the vertical line on the coordinate plane. So this is in the form of 0, 1. And not every linear function has an x-intercept, but every linear function must have a y-intercept. So this is because a horizontal line that only has so a horizontal line that only has a y-intercept is a function, but a vertical line that only has an x-intercept is not a function. So, and if you remember from a couple slides ago, maybe, like the one with the forms of the equations, that y-intercept is in the linear equation. So if you look, this is the first one you guys looked at. So y equals mx plus b. B is the y-intercept here. So this graph shows us the intercepts. So as I said, this this is the x-axis, so the horizontal one right here. And the part of the graph that intersects this line, so for this one, it's this green point right here, that is the x-intercept. And for the y-intercept, it's where the graph intersects this vertical line. So right here. So in the chat, if you guys could, please just type, like, assume this is just going up by intervals of 1, and type what you think the x and y intercepts are for this graph. So we'll give you a second to look at that. And make sure to say like which one you're talking about. So say like the x-intercept is this, the y is this. Yes, so just put the intercepts. Okay, so we got a few answers, and I think most of you guys got the y-intercept correct. So if you can see here, we know the y is gonna be in the form of 0, comma y. And we can see that our y value for this point, the y-intercept, is positive 2. So our y-intercept would be 0, comma 2. And for our x-intercept, we know it's going to be in the form of x, comma 0. And we can see that this is negative 2. So I saw a couple of you put positive 2, but this is going to the left, so it's going to be negative. So it's going to be negative 2, comma 0. So good job if you got that. And if you have any questions, it would be right now would be a good time to ask.
So in the formula, which one is the x-intercept and which one's the y-intercept?
So the x-intercept is the point where, so in the formula, you don't need the x-intercept. You only need the y-intercept. So b is the y-intercept. So in y equals mx plus b, b is the y-intercept, and to solve for the y-intercept, you just plug in 0 into x, and you put in the 2 points and so you put 0 into x, and you put in the slope, and then you solve for b. So yeah, so that's what you need to know. B is going to be the y-intercept, and the x-intercept isn't really used in the equation.
So we'll go over an example. So
yeah, we're going to go over more examples on how to use this and find the y equals mx plus b for different lines.
Okay, so hold on. Okay, so let's see the slope and y-intercepts in action. So we're gonna focus on the y-intercepts more because, as Rishab said, those are the ones you see in the equation. So we're first gonna put this link in the chat, and we're gonna give you guys like 5 minutes to play around with this. So I can't really see which tab I'm clicking, and I don't know how to move this. Okay, so hopefully this is right. No, that is not that one. Not that one. Not that one. Okay, so I'll open it. Okay. Can somebody else, one of you guys, put that link in the chat? That would be very appreciated.
Yeah, I can do it.
Okay, thanks.
Wait 1 second, sorry.
And so while you're doing this, you don't like have anything exactly, some like specific instructions. You're just gonna be moving around the sliding things. So for the slope and the y-intercept, and just note how the line changes as you move, like as you change the values. And if you want, you can like make note of what you notice, because that's what we're gonna discuss. So yeah, the link is in the chat. And it should open just fine for everybody. So when you guys feel like you have had enough time to explore, basically, you can just say in the chat that you're done, so we know when to move on.
And also, like, please ask any questions if you have any, because like it's very critical. Like, since this is the first class of algebra, it's very critical that you understand this, because obviously we're going to be going over much more advanced, many more advanced concepts. So you really have to know this like the back of your hand, or else as I said, you're going to be kind of screwed for later.
But like,
So
if
now's
it,
the perfect time to ask questions.
and we know that you guys are like at different levels of proficiency, so it's okay if you like don't know this or are confused.
Yeah, a lot of you guys, it's kind of hard to make presentations and lessons that appeal to all of your different academic levels. But it's fine if you have any questions. You don't be embarrassed because a lot of other questions. Okay, like I bet the other kids won't care.
Okay, it's what is the y in y equals mx plus b?
The y is just a y point. So when you're doing y equals mx plus b, if you have a point x comma y, you're gonna put in the x value to x and the y value to y. So the y is just gonna be the y coordinate of the point. Yeah. So if you choose a random point on the line, you can plug in the y coordinate, and any point on the line will work. So when you write the equation for a line, you're gonna do y equals, and then you're gonna write the slope x plus b. You're not gonna write the y and the x just because then you're not gonna be able to graph the line. So you just solve for m and b, and you put that into the equation. And you're gonna see examples of that. Yeah, Advika, what you noticed is right. Yeah, that's true. Yeah, I'm pretty sure that's right. And you want to notice patterns like that.
So we'll just give you guys until like 10, 20 maybe, and then we'll start to like share what you guys noticed. Okay, so if you guys want more time, or if you're done, can you like say something in the chat? So say that you're fine with sharing what you learned now, or that you want like a couple more minutes or something. Okay, so we've got a couple of people done. Okay, so we're just gonna go over since I see a lot of you guys are getting finished now. So our first question is, what did you notice about how this, what happened? Hold on. Okay, how the slope changes the line. So type your answer in the chat or you can unmute. So that would be nice too. So there's no like completely right answer, I guess. But so just tell us what you noticed about how the slope changes the line. So how the line looks basically. And oh, the slope was m in your Desmos activity. So from negative to positive, the slope makes it go counterclockwise. Okay, I'm gonna like actually look at yeah, so let's look at what Africa is saying. So from negative to positive, the slope. So from negative to positive, it goes counterclockwise. So I see what you're saying. So like the line is turning counterclockwise. So yeah, that's true. So that's how like the direction of the line changes as you move the slope. Okay, yeah, and we can move on to like the line or stuff now. So, oh, here, hold on. Okay, so we can see that a negative slope, the line goes down as you go to the right. So it's kind of what you noticed, Africa, but like worded differently. And then the positive slope, the line goes up as you go to the right. And what about the y-intercept? So same thing, type your answer in the chat or unmute.
I noticed that when we increase the y-intercept, it goes more to the right, and when we decrease it, it goes more to the left.
Okay, so for reference, the y-intercept was the. So you're saying that the line like moves left and right like this, right?
Yeah.
Yeah, good observation. Good job. So that's because since the point where the graph intersects the y-axis, since that moves up and down, the line also kind of moves up and down or sort of left and right along with the y-intercept. So thanks for sharing. Yeah, so it's like the line is moving up and down, basically. So if you kind of, since it has like a slope that looks like this right now, that's why it's like that. But like if I had a line like this, you can see that it actually just moves it up and down, like that. Okay, now back to the slides. So here we go. Yeah, so increasing the y-intercept moves the graph higher and decreasing it moves the graph lower. So I hope you guys understood that.
Okay, now we're going to move on to parallel and perpendicular lines. So a parallel line means that the line has like no point of intersection, or that the two lines, they don't meet at all during their paths. Like no matter how far they go, they don't meet. They don't touch at all. So parallel lines, this means if two lines are parallel, that means that their slopes are going to be equal to each other. So for example, y equals 1/2 x plus 5 is parallel to y is equal to 1/2 x minus 4. they're not going to touch. And try to wrap your head around this and think about why this is true. Because the lines are at the same like steepness, no matter they can be as far apart as you want from each other, but as long as they're at the same like steepness, they're not going to touch at all.
So I'll just quickly try to sketch what that means so that it's easier for you to understand. So our first one was like 1/2 x plus 5. Okay, so it's like that or something. And then our second one was at -4. So notice that they're not touching right now. And the distance between the two lines, like this distance, it's gonna be constant the whole way. So they're never gonna like get closer and closer to each other until they cross. So since their slope is the same, they're just gonna keep going on forever without touching. So that doesn't like, it doesn't matter if this line was all the way up here or something, it would still, the distance between them would still be the same and they would never touch.
As long as they have the same slope, it doesn't matter how far apart they are. They're not going to touch. They're going to be parallel. And a perpendicular line means that the two lines intersect once at a 90-degree angle. So think of like a really common example of two perpendicular lines. Like where would you see two perpendicular lines? Yeah, a square or like a right triangle, stuff like that, right? Oh, I mean, sure. Oh, plus or a multiplication sign. I guess that works. So you can have like a vertical line and a horizontal line. Like those two are going to be perpendicular. And basically the relationship between perpendicular lines or like their slopes is that they are going to be negative reciprocals of each other. So when you multiply the two slopes of perpendicular lines, they multiply to -1. And so, for example, the opposite reciprocal of -2 would be 1/2. And this is because -2 times 1/2 is going to be -1. Another example is y is equal to 2/5 x plus 2. And, this isn't parallel to y is equal to -5/2 x plus 10. It's perpendicular because 2/5 times -5/2 is going to be equal to -1. Are there any questions about how you find the slopes of parallel and perpendicular lines? So we divide by -1 and then we reciprocate it. And then we make it a reciprocal. Yeah, basically. So you can like divide like 2/5 divided by -1 is -2/5, and then you take the reciprocal of that and that'll be -5/2.
Or so what you're kind of supposed to do is you do -1 over, no. So you say you're dividing like -1 by the slope. So like this. So you're dividing this number by this number. So then this, when you divide, you have to find the reciprocal of the second one you're dividing by. So
Yeah, basically the way I do it is I just know that both of the slopes multiply to -1. I just find the reciprocal and then negate it. Okay. Are there any questions about that? Like finding the slope of a perpendicular line?
this might be a little bit confusing at first.
Okay. Then we're going to move on to some examples. Actually, these are just pictures, but that's fine. So here in Desmos, we can see that we have two lines, y equals 4x plus 2 and y equals 4x minus 3. And these two lines are parallel because they have the same slope of 4. And these two lines are parallel because they have the same slope of 4, and no matter how far apart they are from each other, like we see the y-intercept here is 2, like positive 2, and then the other one is negative 3, they're not going to touch at all. The two lines are not going to touch at all. And then the same thing for perpendicular lines. You have a slope of negative 3 x. You have a slope of negative 3, and then you have a slope of 1/3, and those two multiply to -1, which means that they are perpendicular. And you can kind of look at the graph and tell that, oh, these two lines are perpendicular.
Yeah, so you look at the right angle. So that's how you know they're perpendicular.
Now we have a 5-minute break because we covered all the content that's going to be, we covered all the content in today's class, and we're going to use the rest of the class for going over practice problems and doing a Decimus activity.
Yep, so you can do whatever you want for these 5 minutes or ask a question to us if you want. Now would be a good time. And yeah, just come back to your computer after this timer is over. Okay, so we will continue. So hopefully you guys had a good break and are all back. So, okay, now we're just gonna do some practice problems with the content that we learned today. So our first question is, so just kind of simple, list the coordinates of the following points. So just label your answer like with A is this, B is this, C is this, D is this. So apparently GoPal is gonna give you guys $5 if you get it right. Okay, so I'm seeing a bunch of answers all kind of jumbled up. And we'll wait like a tiny bit more for more people to answer all 4 of the points. Okay, I think we got a lot of answers, so we'll just go over them now. So the answer was, yeah, so A was -2, -5, -2. I think a lot of you guys got that. And then B was -1, -6. So maybe you like counted it wrong a little. I think I see a couple people doing that. And then for C, the point was 0, 1. And then for D, the answer was 2, 5. So good job if you guys got that right.
Okay, here's your second chance to get $5. This graph shows the linear relationship between the time in seconds x for Caroline's walk and the distance in meters y. Caroline is from her starting point. The graph passes through the point 20, 30. According to the graph, how many meters will Caroline walk in exactly 1 hour? And be careful with the units here. Okay, so now I'm starting to see the correct answer, and the correct answer is 5,400. So the person who gets $5 is Vishwa. And since the line goes through 0, 0 and 20, 30, we know that for every 20 seconds, Caroline goes 30 meters. And how many seconds are in an hour? Does anyone know how many seconds are in an hour?
3,600.
Yeah, so it's 3,600. And so for every 20 seconds, she goes 30 meters. So it would be, so like every minute, we can first find how many meters she goes per minute, and then we can multiply that by 60. So she goes 90 meters every minute, and then 90 meters times 60 is going to be 5,400 meters. And are you actually giving money? Maybe.
Okay, so our third question is, at what point does the line 3y minus 4x equals 12 intersect the x-axis? So express your answer as an ordered pair, and an ordered pair is like just like x comma y. So just like your typical point, that's all it's saying like that. And this equation might not be in like a form that's familiar to you, but oops, I did not mean to do that. So all you have to do is kind of just go off of the fact that, well, I can't really say it, but like, I guess your x-intercept format, I guess. Okay, so I'm seeing a lot of -3 comma zeros and 1 3 comma 0. So if a couple more people want to answer, that'd be great. And then we can reveal the answer. Okay, well, we can just go over the answer, I guess. So the answer was what most of you guys said, which is -3 comma 0. And this is because if a point is on the x-axis, its y-coordinate is 0. So what this means is like an x-intercept is going to be in the format x comma 0. So that's why it's like y-coordinate, which is right here, is 0. So we can substitute y equals 0 into the equation. So then we can get x equals 12 divided by -4, which is -3. So all we're doing here is just putting 0 right here and solving for x. So that gives us -3. So our x-intercept is this. So good job if you got it right.
Okay. A line is described by the equation y minus 4 is equal to 4 times x minus 8. What is the sum of the x-intercept and the y-intercept? Okay, so we have one answer so far, and that's -21. Wait, do you guys actually not know what the $19 Fortnite card thing is? Okay, so Hashir and Advika say that the answer is -21. Okay, well, it looks like we're not getting any more answers. Wait, are you guys still working on the problem? Okay, I'll just go over the answer. And the answer is -21. This is because we find the x-intercept and the y-intercept, and then we add them together like the question asks us. So to get the x-intercept, we set y equal to 0, and that gives us -4 is equal to 4 times x minus 8. And then we divide both sides by 4, giving -1 is equal to x minus 8. And then we add 8 to both sides, and x is going to be equal to 7. And so that's our x-intercept, 7, 0. And then for the y-intercept, we do the same thing, except we set x equal to 0. And here we get y minus 4 is equal to 4 times -8. So y minus 4 is equal to -32. And then y minus 4, and then y minus 4, you add 4 to both sides and you get y is equal to -28. So -28 plus 7 is going to be -21.
I had a question. Are we allowed to like add the intercepts like that? Or
What do you mean? Are we allowed to add the intercepts
like
like
is
that?
that like because in the coordinates like it's x comma y, so how are we able to actually add it?
Oh, so that's just like for that.
No, that's just what the question is asking you. The question is asking you to find the sum of the x-intercept and the y-intercept.
Yeah.
And
So that's just like the format of your answer, basically. And someone's asking, how many slides do we have left? Well, I think
We don't have many slides left, but we have like some activities to do.
yeah,
like-
we have like 2 more slides, but we have a fun activity.
Yeah.
So for what value of k does the line represented by the equation 1 minus kx equals -3y contain the point, can't see it, contain the point 4 comma -3? Okay, so I see a lot of you guys are saying -2. Well, not a lot, a couple of you. So if I'll just wait like a couple more, like 10 more seconds to see if anybody else wants to answer, and then we'll go for the answer. Okay, so the answer was -2, like some of you guys said. So good job if you got it right. And we solve this by, so it tells us the equation, but the slope is, well, like the coefficient of x is missing. So, and since 4 comma -3 lies on this line, we plug in, what? Oh yeah, so that's like supposed to be a 4. So x is equal to 4, and then y is equal to -3 into the equation. So that's how we get, and then we just solve for k. So we get k equals -2. So does that make sense to everybody? If you have a question about this one, you can ask it now. Okay.
Okay. Give an equation of a line parallel to the following equation and an equation of a line perpendicular to the following equation. And the equation is y equals 5/8 x plus 6.
So just a hint, this one doesn't have like a specific correct answer. So just put your answer in the chat and we can like look at them. So even if you're like not completely sure, you can just take a guess. So just try your best and yeah.
Okay. All right. So you guys mostly got it correct. And for this one, there are like multiple correct answers. So remember when we have a parallel line that the slopes are going to be the same. So if we have a parallel line, so a line parallel to 5/8 x plus 6, the slope is going to be the same. So it'll be y is equal to 5/8 x plus anything. So it could be like y equals 5/8 x plus 12. And then if the line is perpendicular, the slopes will multiply to the -1. So in this case, it will be the slope of the perpendicular line will be -8/5. And then we can have almost anything for the y-intercept. You can have -8/5 x plus 12, like 12. Yeah. So you can have like -8/5 x plus anything basically.
Mhm.
So yeah, mostly everyone got it right.
Yeah, thanks for answering. And if you have any questions about anything we did today, so any content we covered, now would be a good time to ask before we move on to the fun activity. So if you have a question, you can type it in the chat or unmute. So where did I get the +1 and +8? So that's just like an example answer. So basically, like the only part of this answer that is like required, I guess, is the slope So these slopes are the correct slope. So the parallel one has to have the same slope as the original line. And then the perpendicular one has to have the opposite reciprocal. But these two numbers right here, there's just like kind of showing just a random example of lines that would be parallel and perpendicular. So this could be like any number. The ones that are in the boxes can be any number. So
Yeah, so when finding like perpendicular and parallel lines, you just need to make sure that your slopes are correct, and then you can have like anything for your y-intercepts. Unless like the problem specifies that perpendicular line has to be on a specific point, that it has to go through a specific point. Are there any other questions?
okay, well, I guess we can move on to the fun activity now. So, okay, so we're gonna do a Desmos activity to practice graphing. So this is gonna be like using kind of all of the knowledge you've learned and code. So I don't know if you see that, but if you want to type in the code, you can type in the code, but I'll give you the link so that'd be easier. Okay, so Gopal, can you put the link for the kids in the chat?
Sure.
It's the one that would pop up if you click the like text this link. Okay, so you guys should be able to click on that one and see an activity where you should put in your name, I think. So
Should
you,
Or is it fine if we continue without signing in?
I think it should be fine. I mean, if you want to just sign in with your Google account, that's also fine. Like sign in through Google. But if you want to continue without signing in, I think it should still work. But basically, so it's gonna be like an activity with some slides. And you just follow the directions on each screen. So it's gonna walk you through how to do it and stuff. And then the last slide, it will say, make my challenge.
Where did the plane go?
Hmm?
I did the first slide wrong for the land the plane, and the plane just disappeared.
Oh,
I can't. Yeah, I lost the plane.
so that's not good. But anyways, so if you get to the slide that says make my challenge, type in the chat that you're done and then make your challenges. So that might not make sense now, but once you get to the slide that says make my challenge, just come back to the Zoom meeting and read the directions on this slide. So we can see your answers. So don't just try to like rush through it really quickly, but it's okay if you like mess up. But just try your best and have fun. So we'll have like 20-ish, 30-ish minutes for this. And this is gonna be the last thing we do today. So that's how much time you'll have. And it's okay if you don't finish, but try to get to the make my challenge part, because that would be fun. And if you are confused or have any questions, you can always type your question in the chat or unmute and we'll help you. So what do you do on number 3? Well, I don't exactly know what number 3 is, so look at
For
it.
number 3, let me look at number 3. Number 3 is just for instructions. Just tells you what to do.
Yeah,
On the next 3 slides.
you just go to the next slide if it's like you don't have to answer anything on that side.
Okay, so I think mostly everyone finished, or like, yeah, so mostly everyone finished, or like got at least to the sixth slide, the reflect. And yeah, I see people are like playing each other's challenges and stuff, which is good. Now I'm going to go over this week's homework. So, so as always, the homework is just a short 5-question homework assignment, and I'll post a link to it in the chat. 1 minute. All right, so there's the homework, and you can do whatever you want with it. You can like print it out and then write on it, and then take a picture and submit it, or you can like open it in a new tab and just, or and you can just like type directly over the document and then submit it. But just complete them tomorrow before next class so that you can do the homework is going to be in the classroom, but just complete it by tomorrow morning or like before class so that you can be in the active, so that you can like be actively reviewing with the entire class. Now's the time to ask questions if you guys have any about the homework, maybe, or about any of the content that we learned today, or maybe about the timeline or like the structure of this week's classes.
Yeah, but if you don't have any questions, how could we solve question 3? What was question on the activity? Is that what you're talking about?
On the homework.
Oh, on the homework. Oh, wait, was it from your last class, like
No.
on Friday?
No, right now, the link you just gave.
Oh, if you don't,
We're going over that tomorrow.
yeah. So questions about like the homework itself from today will be going over tomorrow.
Okay. If you guys don't have any questions, then see you guys tomorrow then.
Yep, have a good day, and thank you to everybody that participated and stuff.
Thank you. Bye.
Do you guys
Okay.
have any book or online resource recommendations for Algebra 1 and accounting and probability?
Well, I mean, the biggest resource is basically just AOPS. So, you can like get their actual books or watch, like they have videos, I think, for some parts. And then like there's also like parts of the website, I guess, that gives you questions or like past AMC tests if that's what you're looking at. So I'd say that's your biggest resource. And then also what they give you from like school, like your school textbook or something, that's also good.
Any other? I mean, there's no secret resource that's going to automatically make you better. You have to put in a lot of time and effort and just do a lot of problems. So, I mean, anything that you can find like online regarding counting and probability that's like relevant to like the math class curriculum would help you. But like, if you're talking like direct resources, I really don't have any.
Yeah, me neither. Like as after you learn the content, like you can learn the content from anywhere basically, and then you just practice for the competition. How do you see past contest questions? Well, if you like, um,
How do you see past content or past contest questions? You can just search up like a past contest, like a AMC 8 test, and you'll find them. They're always going to be on AOPS in the library or like the wiki.
like for example, I don't know if you can see this, but like this part, you can see like AMT8 questions from previous years, like that. So if you like click on a random one, it's gonna have problems and an answer key, and I think like explanations. So this website is good.
Okay. Thank you.
Mhm. So yeah, if you guys don't have any more questions, you are free to go. Bye.
Hey, Pratham, do you have any questions or?
No.
Okay,
Okay.
that was